This is the presentation for the Advanced Data Mining CA1 for Stephen, Danny, Anna and Louise, Team C. This presentation describes how we took the dataset for Prudential and which contains fields regarding products, personal information, employment, family history, etc. The techniques we applied to this include PCA versus Brunta versus mutual information, K-means, and other plotting and hierarchical methods. Okay, so if we jump into our OR studio and we can begin reviewing our script. The script contains references as well as links to libraries. It shows how we imported the Prudential data from the Kaggle site, and then it describes how we went about identifying missing values and then going through these. Of the missing values, we had 13 fields. Of these, 4 included 4 columns of missing data, on which we imputed these to put in means values, and for the remaining 9 values we inserted nulls in these columns. And our script here describes how we did that. Also, we normalized categorical variables using the min-max transform to put in values between 0 and 1. We also removed the height and weight variables because there's a BMI variable which correlated the data, and if we run this correlation view, we can see here this is how the variables relate to each other, and I've plotted this in Excel, and I tried to put some color on it, and we can see here that the values with from 0.8 to 1 will have a greenish value. You can see here there's a couple here and a couple there, but not that many. Okay, so it doesn't seem to be a correlation on these fields. They all have very low correlation values. Okay, so we jump back into our OR studio. Here we describe how we introduce PCA. And the first approach to this is to use a correlation matrix, like an elbow in these eigenvalues under which we can discount. There seems to be kind of a gradual drop off, but I suppose there does seem to be some more meaningful components, principal components to the front. We can also apply a different covariance matrix method on this also. And so we just run this through. Have a look at the plot on this one. This explains again, slightly different, but again 3 principal components in our data set. So we move on to some graphical examination of the data and look at our 3D plot of this information of the 3 principal components. We see this 3D graph gives us quite a nice representation of the data into which we can zoom into and take a look at the color-coded separation. Now this shows us two distinct blobs of information, but I guess we'll try and continue on and try and make sense of this elsewhere in our scripts. So back in the OR script here, we are introducing some unsupervised clustering to K-means, and if we run this, we can then have a look at the response variables. Okay, and we can see here in these 2 sets of data that the response variable doesn't really map to the counts that we have on in our 8 principal clusters here. So there doesn't seem to be a mapping between these 2 sets of data at this level. If we introduce the cross-tab analysis on this. And we'll just slide this across. It shows again something similar where the values are linked between the predicted and the defaults, and again this isn't showing us any clear correlation between response and cluster variables. So moving on to to look at this in this information in a 3D plot, we can look at individual fields, or we can look at our k-means cluster, and let's just have a quick look at that. Okay, so this is showing us quite nicely lots of colors, lots of with our 8 clusters, and we can zoom in here. We can see the different clusters from their colors and how they are very closely mapped out in the same space. Again, there's a separation between the top and the bottom here, but within those two groups, everything seems to mix in together, which is interesting, and it's very nice to see it through this representation. Okay, so we move on and we'll have a look at some hierarchical clustering techniques, such as dendrograms, and with this we produce a sample of the data set, and we can introduce some different measuring techniques that are listed here. And so for our first example, we'll have a look at the complete measuring method and run that, and we can plot it here, and this shows us quite a nice dendrogram, and below here it's boxed off with our 8 clusters, and you can see how these are quite, again, as we would expect, quite evenly grouped, and again coming up to 2 main clusters, which again it reflects our 3D graph. And if we have a look at the centroid approach for measuring this, and run that, and run these in again, we'll see that it's subtly different, but it does change. And so it just, I suppose it means that you should be cautious about selecting the method you use in these actions.
As an alternative to the principal component analysis to try and identify features that are of interest, we looked at a couple of different ways. So we looked at Baruta, which is a wrapper for multiple random forest algorithms, and this will actually produce a list of the primary values. It allows to discard features that weren't actually impacting on the response variable that we were looking for. We were looking at how we would use clustering to actually predict values out of a Kaggle competition to try and create a result set that we could submit to Kaggle. So what we thought we'd do is, if we loaded the trained data set and tagged it as train, and then load the test data set and tag it as test, and then bind those two together so we have some way of filtering them later, and then actually apply all our data cleansing that we've looked at already to the total data set, and do that clustering. In this case we're using k-means plus plus to do the clustering. Then what we can do is we can get a histogram of the response values versus the clusters, and then try and cross match between those, and then map out those predicted values and say, well, in the training set we don't have a response value, but this is what our predicted value is. Then we filtered those out for the test data set and submitted to Kaggle. We did this, so we loaded in our data again. This is just all pretty much a repeat of stuff that happened earlier. We imputed some of our missing values, and we just pulled in our list of fields. So this is our list of fields that we've identified through Baruta or through the mutual information algorithm that have the most impact on the result. And then we tag the train database with train. Then we do some normalization of our categorical variables. Then we do the same thing exactly with the test data set, map the exact same list of fields except in the test data set we won't have a response variable at the end, so we do create a dummy response variable in there, and then we do the same with our categorical variables there. Combine the two, and then we use a k-means plus on the first 50 features and try and find 8 clusters. When we table these out, we can see that the responses, so these are our top responses and these are our top clusters. So essentially we've just mapped them by the number of records in each, although there's some reasonably good matches. So we've said if it's cluster 5, we're going to say that that's response 8. If it's cluster 1, then we're going to say that that's response 3, and we've got this little if-else chain here that will apply those values to there. And we extracted that out, and we put the results out into Kaggle, and we actually got a result of 0.244, which is not an outstanding result in Kaggle, but it is an interesting result. So the conclusions of our investigations is that clustering is a great approach for unsupervised discovery of patterns in our data, but isn't a great approach for the type of predictive Kaggle competition that we chose to enter, and probably other solutions such as perhaps the C50 or 5.0 decision tree or random forest or XGBoost, for example, might be the better approaches there.